Earth orbits around a star that is about 93 million miles away. The distance is just right. Earth temperatures are neither too hot nor too cold for life to exist. On Earth, there is oxygen to breathe, an abundance of water, and a fertile soil. An invisible magnetic field protects us from the sun's radiation. And our atmosphere filters out most of the sun's harmful rays. These are the conditions that are necessary to support life as we know it. We wonder if the same conditions for life exist elsewhere. We ask, what is our solar system really like? How big is the universe? To discover these things for ourselves, we'll take an imaginary flight, an impossible flight that defies both time and space. We are spaceborne. Flight time to the moon is about 65 hours. The distance, about 238,000 miles. The lunar soil is much like that of Earth. It includes volcanic ashes and rocks. There is a death-like silence here. This gray, dust-covered wasteland, pockmarked with ancient craters, has no air, no surface water. At noon, the moon's surface is hotter than boiling water. At night, it is minus 250 degrees, colder than any place on Earth. It appears that life has never existed here. We continue our imaginary flight, curving inward, closer to the sun, increasing our speed towards Venus. We catch up with the planet. The gravity from Venus pulls us toward it. Earth is now so far away. It takes our radio messages, though they travel at the speed of light, 4 minutes to reach Earth. The Venus rotation is opposite to that of Earth. Its surface temperature is 700 degrees. Its atmospheric pressure may be 100 times that of Earth. The swirling clouds are mostly carbon dioxide, with very small amounts of oxygen and water vapor. This glowing, nightmarish world has no protective magnetic field. There can be no life here, as we Earth people know it. Our flight continues. We head to the orbit of the planet Mercury. Only 36 million miles from the Sun. Mercury's dark side is freezing cold. But its light side must be so hot that metals would flow in molten rivers. There can be no life here, so near the Sun. And our Sun. It is an atomic powerhouse with a core temperature of 20 million degrees. Each second, more than 500 million tons of hydrogen are converted into helium, and millions of tons of matter are transformed into radiant energy, which is poured out into space. Solar prominences rise like the flaming sheets of a twisting tornado, sometimes reaching 1 million miles into space. Mercury and Venus are too hot to support life as we know it. So we return, past Earth, to look outward, away from our Sun, along a flight path that will lead to the red planet, Mars. Flight distance from Earth to Mars is about 300 million miles. Flight time is 7 months. Radio messages from Mars take 12 minutes to reach Earth. Mars is only 1/2 the size of Earth. Its atmosphere is clear, mostly carbon dioxide. The atmospheric pressure on the surface of Mars is equal to at least 100,000-foot altitudes on Earth. There is little oxygen and no nitrogen, the elements that make up 99% of Earth's atmosphere. Midday ground temperatures are comfortable, but the nights are far below freezing. There are small amounts of water, mostly in the form of frozen ice clouds. The South Pole is covered with frozen carbon dioxide snow, perhaps mixed with particles of water ice. Temperature at the South Pole may get as low as -200 degrees. There is no planet-wide protection against ultraviolet rays, which are harmful to Earth-type life. The surface of Mars is pockmarked with craters, more moon-like than Earth-like. There are gentle slopes, though the crater interiors are depressed thousands of feet. However, this hostile planet must still hold our best hope for finding some kind of extraterrestrial life within our solar system. We now move outward, beyond this place in space and time. We cross a belt of 100 million miles of icy orbiting asteroids. Space matter ranging from the size of dust and pebbles to rocks and islands as large as 500 miles in diameter. Next, we cross the orbit of the mighty planet Jupiter. Master of 12 moons. "300 times the mass of Earth. It is cold here. Jupiter's atmosphere is made up of hydrogen and helium, with frozen fogs of methane and ammonia. We coast on to Saturn. This huge planet has a core of rocks and metals overlaid with sheets of gases similar to those of Jupiter. From one of the 9 moons orbiting its surface, we see streaming symmetrical rings of icy fragments. Space materials, perhaps of additional moons in the process of being created, or the debris of those somehow destroyed. Out from here is the orbit of Uranus. 1,800,000,000 miles from Earth. Next is Neptune. 2.5 billion miles from home. Finally, there is the last planet, lonely Pluto. We look back. We are nearly 4 billion miles from our sun. So far away that it seems only slightly larger than a distant star. There is almost no light. The temperature nears 380 degrees below zero. Earth, man's oasis, as well as our whole solar system, is lost in the dim darkness and distance of space. But what is beyond? The speed of light is 186,000 miles per second, more than 600 million miles an hour. And yet, if we could travel at that fantastic speed, it would take us 4.5 years to journey to Alpha Centauri, the nearest star, 26 trillion miles away. In this vast wilderness of space, there are stars of all sizes, colors, and descriptions, all billions and trillions of miles apart. There are single stars, like Ross 154, smaller, cooler, and redder than our own sun. Hot blue-white stars, like Vega, remain uncounted. As they lose their energy, some stars grow to be giant red suns like Antares. Larger than the entire orbit of Mars. Eventually, this star may collapse to form a tiny white dwarf star. So heavy that a handful would weigh 25 tons on Earth. There are pulsating stars, like Mira, that contract and expand at regular intervals. Their light output decreasing and increasing. There are nova and supernova, star tragedies of vast proportions. Nuclear explosions in which a star blows off into space excess gaseous material amounting to several times the mass of our solar system. Stars known as pulsar stars emit bursts of radio energy at regular intervals. Some at frequencies up to 300 times each second. There are double, triple, and multiple stars. And globular star clusters that may contain 100,000 stars. In this vast arena, there are glowing shrouds like the Great Crab Nebula. Enormous clouds of gases and dust that reflect in the short-wave light of blue-white stars. It would take jet aircraft 150 million years to cross this great expanse. Other nebulae, like the Horsehead, have no nearby stars for illumination. Thus they are seen as dark silhouettes. Beyond here, there are more stars, all converting matter into energy. Some shed hydrogen and helium in glowing spirals millions of miles long. All we have seen are members of our own Milky Way. A galaxy of 100 billion stars, 80,000 light years in diameter. Once each 500 million years, the galaxy rotates like a giant wheel. Our own star, the Sun, and our solar system is 30,000 light years from the center, lost in the haze of individual stars. Still we move outward. Another galaxy of stars is Andromeda, a complex similar to our own Milky Way. On this trackless road, there are millions of galaxies. Each with its own million, billion stars. We are 50,000 billion miles from Earth. But there is no known boundary to the cosmos. We may be looking towards infinity. What captive island planets orbit these uncounted stars? If only a few of the stars have planets, and only a few of the planets have pleasant climates, what beautiful civilizations might spring and thrive there? We do not know. So man continues his search. He journeys to see what he will find. Perhaps one day, in a cosmos so vast as to defy everyday measures of space and time, he will find the answers to questions as yet he cannot even ask.